Okay, we continue on. Question 22. Draw the approximate path of a ray of light travelling all the way through the following prisms, i.e. starting in air and finishing in air. Identify the normal where each case of refraction occurs. Alright, our first case of refraction is going to happen here. There's our normal. Air to glass. Greater density. That means it's going to bend towards the normal. So we're going from air, where we know that n equals 1.0, into glass, and we're told that that's n equals 1.6. So greater density, bending towards the normal. So that means that this angle here is greater than that angle there. Angle of incident is greater than the angle of refraction. Okay, so for the second one, we draw our second normal, and we're travelling from glass to water. And we can see that water has a lower absolute refractive index, so that means it's going to bend away from the normal again. So towards, away, and then we're back into air, which is, so it bends away from the normal again. We're going to a less dense medium away from the normal. So I put my normal in again, and it'll bend away from the normal. And the other point of reference here is that it should come in at, or go out at the same angle that it came in. Okay. Alright, second one. Our incident ray comes in at 90 degrees. So if it comes in at 90 degrees, there will be no refraction, so it goes straight on. Now, this is the interface between our glass, which we've been told is N1.6, and going back out into air, which is N equals 1.0. Now, normal goes at 90 degrees to the surface, so that's our angle of incidence. And if it's going to a less dense medium, it's going to bend away from the normal. So we should have something like that, so that the angle of refraction is larger than our angle of incidence. Okay, question 23. What's the absolute refractive index of quartz if the incident ray of light travelling from quartz to air at 35 degrees produces an angle of refraction of 26? So the angle of incidence is 35 degrees. The angle of refraction is 26 degrees. Let's sort out our N1 from our N2 here. So we're going from quartz. So quartz is our N1. And that's, we're not sure what that equals. Quartz to air. Air equals N2, and that is 1.00. Alright. Snell's law is sine I over sine R equals N2 over N1. Sine I, sine 35 over sine 26. N2 is air, it's 1. Okay, so written out my formula, substituted in. Let's simplify it now, and I'll move over here. 35 sine. Okay, let's simplify our left-hand side of the equation. 0.57 divided by 0.44 equals 1.0. 1.3 equals 1 over n1. Okay, to get n1 by itself, let's multiply both sides by n1. So we have 1.3 n1 equals 1. And then we do 1.3, divide both sides by 1.3. So n1 equals 1 divided by 1.3 equals 0.77. Now, I've got to apologise because what has happened here, and when I see a number less than 1, I know that it's wrong. And it's wrong because these angles are around the wrong way. And think about it. Travelling from quartz to air, so we've got our higher density. Quartz to air produces an angle of refraction of 26. So that's 26 in here. And if that's greater density to lower density, then this should be actually less than 26. It's 35, so these angles are actually around the wrong way. So this is the correct answer to the question, but only because the question is wrong. You should never see an n value less than 1, so that is an error, that these angles are around the wrong way. Okay, let's move on anyway. Light travels from glass to water. The incident angle is 33. Calculate the angle of refraction. Okay, from glass. So glass, from glass, N1, 1.6. To water, incident angle, 33 degrees. Angle of refraction is the question mark. So, Snell's law, sine I divided by sine R equals N2 over N1. Substitute our numbers in. Sine 33 over sine R equals 1.33 over 1.6. Okay, and we can simplify this side of the equation. We've got numbers, 1.33 divided by 1.6, 0.83. And we can also simplify sine 33. 33 sine is 0.55 over sine R. Okay. Times both sides by sine R. Okay, and we want to get R by itself, so we divide both sides by 0.83. Two numbers together, so let's work them out. 0.55 divided by 0.83 equals 0.66 equals sine R. Now to get R by itself, we need to do the opposite of sine, which is inverse sine. So we inverse sine that, gets rid of that. So we inverse sine this, 0.66 inverse sine. R equals 41.5 degrees. Okay, it's going from more dense to less dense, so it bends away from the normal. So if the incident is 33, our answer should be more than 33, so 41. So, okay, that's right. Alright, this one. Draw a diagram that demonstrates why the position of an object underwater appears different to its actual position because of refraction. Be sure to indicate the direction of the light rays, include the normal, show the perceived position of the object, and its real position. Alright, so here's my fish. And the light ray bounces off the fish. And it goes like this, let's say. refractions occurring here. We need to draw our normal in. More dense to less dense, so it bends away from the normal. Okay. So remember the light's bouncing off the fish, that's why we can see it. Now here's that's my eye. So that's the path that light takes that reaches my eye, and my brain makes a straight line here, and so misinterprets the fish to be there. Okay, so let's make sure I've done my labels right. Be sure to indicate the direction of the light rays. Okay, I've got my arrows. Include the normal, I've got that. Show the perceived position. So maybe I should write, I think that's EI, perceived position. There, real position. Okay. Alright. How much have we done? That's going to be about 10 minutes, I think. Alright, I'll turn the record over. I will stop this and I'll come back with another part.